This video is going to be the last part of Chapter 10, looking at sections 10.4 and 10.5. So we've talked about how electrons are going to be really important in reactivity and bonding. And so now that we know different electrons are going to be in different orbitals, remember, if we say we have an electron coming from an atom in the third period, we could have them coming from our 1s level, our 2s, our 2p, or even our 3s or p levels. And so in order for us to keep track, referencing which elements we're talking about, and inside those elements which electrons we're dealing with, we're going to develop sort of a notation or a shorthand. And so these are general guidelines. I'm going to make things a little simpler for us, but we're only going to be able to have 2 electrons in any s orbitals, and we're only going to have 6 in p's and 10 in d's. So we actually can see similar trends for groups on a periodic table. So you can see as we go down group 1, we're talking about the electron 1s1, 2s1, 3s1. This means that it's the first electron on that orbital. So for example, sodium, we would have that 1 extra electron in the 3s orbital that we know loves to give away in order to retain its configuration of neon. So and another example would be looking at group 7. We always have the same format. We have an S2 NP5, and we know that it wants to grab that extra electron, giving us its 8 electrons acting like a noble gas. And so we will often use our noble gases as a way to build up, keep track of how many electrons we have. So we'll start off with a simple one. All you need to do for these questions is to add up your superscripts. We know that's dealing with individual electrons. So when we add up our superscripts here, we're seeing S2, S2, P6, S2, and P6. When we add those superscripts up, those are going to be our total number of electrons. Those equal 18, so we're going to have an argon element. So since it has 18 electrons, we can match that from the periodic table by looking at its atomic number. Now, we also can see these with brackets around here. So basically, this is a way of adding on to a noble gas. So we're looking for the element here that is 1 more than argon. We know, looking at the periodic table, it will be potassium, 1 more electron than argon. This is going to be in our 4th energy level. Last one, here we have neon, 3s2, 3p1. So we're going to look for 2 plus 1, 3 extra electrons over neon. We know neon has 10 electrons, so we're looking for the element that has 13. That's going to be aluminum in the 3rd energy level, n equals 3.